if x is the simple interest on y and y is the simple interest on z or z, the rate percent and the time being the same in both cases, what is the relation between x, y and z? So here we have been given two scenarios which are interrelated. So the first scenario is that an amount of y has been put on simple interest. So the principal amount is y and x is the simple interest earned. So the simple interest is equal to x. In the second scenario, an amount of z has been put on simple interest and the simple interest earned is y. So in the first case the simple interest is x, the second case simple interest is y. Now the rate percent is the same, so rate is equal to r percent per annum, and here also rate is equal to r percent per annum. The time frame also is the same, so time is equal to t and time is equal to t. Now with this information we have to find out the relationship between x, y and z or z. So let's take the first case. So we already know that simple interest is equal to PRT by 100. Now in the first case simple interest is x, principal is y, rate is r, time is t, and this divided by 100. So this is our case number 1. Now in the second scenario, again simple interest is equal to PRT by 100. Simple interest is equal to y. So y is equal to, principal is z. So z multiplied by r multiplied by t divided by 100. So this is our second scenario. Now we have to find out the relationship between x, y and z. So we have to eliminate all other variables and then merge these two equations. Now we have a common point which is y. So y is in the first scenario and it is also there in the second scenario. And we also have a common factor which is r and t. So r and t is also in both the equations. So what we can do is we can express this equation, the first equation, in terms of RT and put that value which will be in terms of x and y into equation number 2. So that way we can eliminate r and t with values of x and y, and then we'll be able to find out the relationship between x, y and z. So let's do that. So in the first equation, let's have RT on one side and everything else on the other side. So this becomes RT is equal to, so 100 goes on top, so 100 times x and y comes down, divided by y. Now let's put this in this equation. So y is equal to z multiplied by 100 times x divided by 100 multiplied by y. So this is basically z multiplied by RT. So z multiplied by 100 times x, and then y was the denominator here which we brought down. So 100 multiplied by y. So we can bring this y on the other side, but before that let's cancel these 100. So y square, y multiplied by y is y square, is equal to x multiplied by z. So this is the relationship between x, y and z.